In this video, we'll introduce the idea of what a quadratic equation is and one of the methods for solving quadratic equations, which is by finding square roots. So at this point in our Algebra 1 careers, we know how to solve linear and absolute value equations, or at least for sure you should know how to solve linear equations. Linear equations only had variables with powers of 1. Absolute value equations also had powers of 1, but had the added benefit of absolute value bars, and those absolute value bars caused us to get 2 answers instead of 1. What we're going to deal with today is going to have a similar thing happening to those absolute value equations. Today we start looking at quadratic equations. The word quadratic is going to tell us something very specific about these equations. These equations have a variable with a power of 2. So if there's no variable with a power of 2 anywhere in our equation, it is not a quadratic equation, and we would use different methods for solving it. If there is a higher power somewhere, we would use different methods. But if there's not a squared at all, or anything higher than squared, then that's a linear equation, and we'd use another method. So we'll learn a lot of different ways to solve these equations, but the first one is pretty simple. It has to do with the idea that I can actually look at x squared equals 25, which is a quadratic equation, and I can figure out what that answer is pretty easily without doing any work. Because what number, when you square it, equals 25? That's what's being asked here. The obvious answer is 5, but there's another answer. Because if I'm squaring it, and it has to equal 25, then negative 5 also works, because negative 5 squared is negative 5 times negative 5, which is still positive 25. And so what happens here, what we're actually going to use in this method is the idea that I can square root both sides of this equation, and I can come up with what the answer is. And the square root of x squared ends up being just x. The square root of 25, though, we have to know that we'll get a positive and negative answer. We can also write this as x equals plus and minus 5. This is a special symbol that combines positive and negative, and it's saying in a shorthand sort of way that we actually have 2 answers, a positive 5 and a negative 5. So what we want to do now is, first let's make sure we understand the idea of square roots. We want to find all the square roots of the numbers that are given here, or we want to write that there aren't any. And we can check the results by squaring each root. So the square roots of 81 are any numbers that when it multiplies times itself, you get 81. So the obvious answer is 9. And the less obvious answer is negative 9, because when I do negative 9 times negative 9, I get positive 81. On part B, what numbers do I multiply together to get a negative 121? Well, if you think about it, the only thing that actually works is negative 11 times positive 11, and that's not going to work because we need the exact same number to be happening twice. So it turns out that we can't take square roots of negative numbers, or at least we can't take them and get real numbers, which at this point in our math careers is what we're used to working with. All of our numbers that we use normally are real numbers. There is another kind of number that's not real, and when you get to Algebra 2, you will talk about those, or you may do it later on in Algebra 1. But for now, all we care about is that this negative makes there not be any square roots for our purposes. If we end up with a decimal here, that can make things tricky. The best way to think of this is I know what multiplies to get 4. It's 2 and 2. So I want to think about where the decimal needs to be so that I'll have 2 decimal places here. You might think that 0.02 is the way to go. And that's why we're checking our answers by squaring them, is because 0.02 times 0.02 gives you a 4, but look how many decimal places we need. We need 4 of them to make that happen. So this actually isn't the correct one. We need fewer decimals, so let's try 0.2. 0.2 times 0.2 gives us 4 with 2 decimal places. So that is the correct answer. We want positive and negative 0.02. Now, the difference between example 1 and example 2 is example 1 asked us what are the square roots of this, and so we were able to get positive and negative answers. But here, we're being asked to evaluate an expression that already has a square root. And that's important because this square root on A is already negative. And so what I do is I say the square root of 4 is 2, and I look at the sign in front, and that's what decides whether this is positive or negative. So if I am doing something in math that causes me to decide to square root something when the symbol wasn't there before, that's when I get a plus or minus sign. But here, whenever I'm evaluating things that already have square roots, they are already either negative or positive, or they could be both, but it has to show up in the problem. So for instance, here on B, once we figure out what this answer is, it's only a positive answer because our square root here does not have a sign in front, which makes it positive. And that is one of the trickiest things for students to pick up on in this whole scheme of things, is the difference between if I choose to take a square root versus they told me to take the square root by having the symbol there. Now, if I ignore the decimal on B, the square root of 144 is 12. So if we use what we learned on the last example, we'll probably want to try 1.2 and see if that works to give us the right decimal location. 1.2 times 1.2 is like 12 times 12, which is 144, but it has 2 decimal places, so that is the correct answer. Now we're actually going to solve some equations. We will solve it or write no solution. We're going to write the solutions as integers if possible, which integers are like whole numbers, and otherwise we're going to write them as radical expressions. So when we get to one of those, you'll see what that means. We're going to start by getting x squared by itself, just like we would if this was a regular x. We're going to use the same kind of rules that we used for linear equations. So we divide by 2 first. And the reason that we divide by 2 first before we square root, which is our next step, is because if I square root at the beginning, then I'm trying to figure out what square root of 50 is. I would also have the 2 in front of x underneath the square root, and that's not super helpful. That's not as easy to solve as if we just move the 2. So because we took the square root in this equation, this is going to be a positive and negative 5. The square root wasn't there at the beginning. We had to decide to do it, and that's what makes us have 2 answers. It's also 2 answers because what 2 numbers, if I plug into x squared, give me a positive 25, positive 5 and negative 5. Part B, let's subtract 2 from both sides. Again, following normal linear equation kind of steps where we're trying to isolate the x squared. We're going to divide both sides by negative 1. And then we will square root both sides. And this is where we end up with a problem because we cannot take the square root of a negative number. And so we would say there is no solution to this equation. And again, there's no real solution. We actually can get imaginary solutions to this, but if you're in Algebra 1 and you're just learning this for the first time, then that's probably not something that you have to worry about yet. So, example 4. We are going to use the same techniques we've been using. We're going to add 5 to both sides and get 2a squared equals 14. Divide by 2 and get a squared equals 7. I'm going to square root both sides. And this is what it's talking about when it says otherwise write them as radical expressions. I know that my answer is going to be positive and negative because I took the square root. But when I say, okay, what's the square root of 7? There isn't an actual square root of 7 that ends up being an integer. It says write the solutions as integers if possible, otherwise write them as radical expressions. So as it turns out, as mathematicians, we would rather leave this as plus and minus square root of 7 and call it a day, as opposed to the only other thing that we could do with this is put it in our calculator and get the decimal, which is 2 point something. And the reason is that the square root of 7, when I put it in the calculator and get 2 point, I don't know what the actual numbers after that are, we end up having to round that number because it goes on forever. And so as mathematicians, we would rather just write it as square root of 7, knowing that we haven't rounded and we haven't messed with the integrity of our answer. It literally is square root of 7, whereas if we put 2 point something, then we're saying it's about 2 point something because we aren't listing all of the decimal because we can't, because it goes on forever. So that's what it means when it says otherwise write them as radical expressions. Now on part B, I'm going to subtract 10 from both sides. And divide by 6 and get x squared equals negative 1. So again here, when I square root and I've got the square root of a negative number and I go to write x equals, well, I can't square root a negative number. At this point in time in Algebra 1, I don't know how to do that. So I say instead that there is no solution. That is all for section 9.1, which is about solving quadratic equations by square roots. Like I said, there are other methods for solving quadratic equations and lots of other things that we can do with quadratic equations. So you can look for other videos that will be posted soon if you need help on those other methods as well.